Welcome back out there, all you Radio Land listeners. We move over to the law of cosines. I know you're wondering right now because I can tell, why in the world do we need the law of cosines? Well, that's a good thought. Because anytime we have a right triangle, we can use SOHCAHTOA. This is one thing. Okay, anytime I have two angles and one side, which would make this angle side angle, or angle angle side, we don't care which one, we use the law of sines. Anytime I have two sides and one angle opposite one side, okay, we get side side angle. This is the ambiguous case. And it's possible you would get two triangles on that, but maybe not. But the important thing here is two sides and an angle across from one of them. And so what that leaves is three sides, or two sides and the included angle, which is side angle side. Well, guess what? None of these other ways are going to work for these. Okay? So that's why we need the law of cosines. Of course, cosines are cosines adjacent over hypotenuse. So we're going to use this. Okay, and here's the proof of the law of cosines. It's where the law of cosines comes from. And then once we get this, there's not a triangle in existence that we can't deal with. Because if it's right, we're going to do that. If we have two angles, we're going to do this. If I have side side angle, I'm going to do this is law of sines 2. But if I have three sides, or if I have a side angle side, then I can use the law of cosines. It'll always work on these two cases. So as we work problems in the future, they're going to mix all these together. You're going to have to pick the one that matches. So I would keep this thing handy because you're going to take a test on Friday. Okay, so here's the proof. Once upon a time, there was a triangle. We'll call it capital A, B, capital C. There's the altitude. We'll call it H. We have three triangles here now. The left one, the right one, and the whole thing. And let's see, there's capital C, so this is little c all the way over there. That's capital A, so this is little a all the way over here. And that's capital B, and this is little b, which is that entire side. Okay, so what we want to do is we want to go into triangle 1 first. And we're going to call that segment right there, we're going to call it the letter X, since we don't know what it is. And then we're going to do the Pythagorean Theorem on that. Okay? We just did the Pythagorean Theorem right there. We're going to subtract x squared from both sides. And I'm going to get h squared equals c squared minus x squared. Okay, so we got that first one. We solved it for h squared. We don't want to take the square root of both sides. We won't need to. And then over here on the second triangle, I need to figure out what this one is right here, the distance between these 2 points. How long is it? Well, we know the whole thing is b, and this little left part is x, so guess what? That part is b minus x. It's the whole thing. If I told you this was 20 and that was 5, you would tell me this was 15. You would subtract them. Now let's do the Pythagorean theorem on this side. I've got h squared plus b minus x squared equals a squared. Okay, that's not too bad. Oh, look here. Square binomial in my head. Square the first one, multiply the 2 and double it, square the last one. And now we have a formula. Now, if you need to, if I lost you on that, never fear, come over here and do b minus x, b squared minus bx and plus x squared, and you get b squared. There's 2 of them right there, which is why we multiply those 2 and double it. Circle this because it's h squared, and we want to go substitute it right there, c squared minus x squared plus b squared minus 2bx plus x squared equals a squared. Oh, this is nice. Look right here. That little x squared and that little x squared disappeared, and that gives me c squared plus b squared minus 2bx equals a squared. Okay, so we're getting along on this. And it would really be nice if I could substitute for the x, okay? That would be really nice, because then I would have all a's, b's, and c's. Little a, little b, little c are all sides. So we're pretty good on that. So let's see. I need some formula that has x in it, but is not squared, okay? So this is where we're going to use cosines adjacent over hypotenuse. So look in triangle 1 right here. The cosine of capital A is adjacent over hypotenuse. Cosine of A, that angle, I'm at this angle. This is adjacent to the angle. H is opposite the angle. C is hypotenuse. But I want x in it. I've already done sine, but sine would be h over c. Cosine is x over c. Let's cross multiply. X is c cosine A. And then let's take this and let's go substitute it right there for x, and I get c squared plus b squared minus 2bc cosine capital A is a squared. And now notice I've got a formula that has a cosine in it, hence the title, the Law of Cosines. And this is the formula that's called the Law of Cosines. Okay, so take notes on this. This is the proof where it comes from. We use the Pythagorean Theorem. It's actually pretty straightforward. So now we go work some problems using the Law of Cosines, but we'll do that on the next video. So here's this whole page. Now we can handle any angle that comes at us, any triangle that comes at us. Right, two sides, a side angle, three sides, a side angle side, we use this one. So this is my new formula for the law of cosines. And we'll return.